Imagine scooping up all the salt from the entire ocean. Think about that for a moment. You could build an enormous wall of pure salt. This wall would be truly gigantic. It would stand 500 feet tall. That's taller than a 50-story skyscraper. Now imagine its width. This massive salt wall would be 1 mile wide. This incredible wall would stretch all the way around the Earth's equator. That's a staggering 24,901 miles long. This is enough salt to cover entire continents. Our planet's vast oceans hold an unbelievably immense amount of salt. Have you ever wondered where all that salt actually comes from? Why isn't the ocean just fresh water, like a mountain lake? Join us on an amazing journey. We will dive deep into this salty mystery. We will uncover surprising facts. Get ready to have your mind blown. The ocean is a truly vast and mysterious place. It covers more than 70% of our beautiful planet's surface. It is home to an astonishing array of creatures, from tiny plankton to giant blue whales. Whales are as long as 3 school buses. The ocean gives us much more than beautiful views. It plays a crucial role in Earth's climate. It helps keep our planet from getting too hot or too cold. It also produces much of the oxygen we breathe. Every second breath you take comes from the ocean, but its most famous feature is its unmistakable taste, a taste that is distinctly salty. We drink fresh water every day. Animals drink fresh water too. But ocean water is too salty for us to drink. It would actually dehydrate us. So why is it so incredibly different? Where did all this immense salt begin its journey? It all started a very, very long time ago. Billions of years, in fact. Let's uncover this ancient secret. Let's begin our grand adventure on land. High up on mountains or rolling hills. Fresh rainwater falls from the sky. This water is pristine and pure. It's like the clean water you drink from a tap. But as this rain lands, things begin to change. It immediately starts to move. It flows across exposed rocks and through the soil. Think of rain as a gentle, patient sculptor. Over vast periods, it slowly wears down the land. This process is called weathering. As water trickles, it picks up tiny bits. These tiny bits are called minerals. Many of these minerals are actually various types of salts, not just table salt, but many different kinds. These tiny particles dissolve into the water. Just like sugar disappears in your tea, the water then becomes very slightly salty. It's now a very dilute solution. This mineral-rich water then flows into small streams. These streams then merge together. They form larger, more powerful rivers. Rivers are like superhighways for water. They carry this slightly salty water. They journey all the way to the vast, waiting sea. Every single river on Earth does this. They are constantly delivering tiny loads of dissolved salt. But wait a minute, rivers are not salty. Why is that? Rivers are always on the move. They flow quickly to the ocean. Minerals don't have enough time to build up. Fresh water constantly replaces them. But the ocean is different. It acts like a giant collecting basin. It's like a huge, deep bowl. All those tiny bits of salt keep accumulating there. They gather and concentrate. This process has been happening for billions of years. Imagine billions of tiny sprinkles of salt, all adding up one after another. Over time, these tiny sprinkles become a giant mountain. Now let's embark on an even deeper journey. We're going to plunge miles below the surface. We're heading to the mysterious ocean floor. Here, in crushing darkness, the Earth's crust is cracking. Imagine our planet's surface as a giant puzzle, with enormous pieces. These pieces are called tectonic plates. They are always slowly moving. Along these deep cracks, something amazing happens. Cold ocean water seeps deep into these cracks. It goes miles beneath the seafloor. Down there, it encounters intense heat. It's heated by molten rock, called magma. The water becomes superheated, much hotter than boiling water. But it doesn't boil. Why not? Because of immense pressure. The weight of all that ocean water above it. This hot water also becomes very acidic, like a strong cleaning solution. It then reacts with surrounding rocks. It dissolves even more minerals. It pulls out different kinds of salts and metals too. Finally, this superheated mineral-rich water bursts out. It erupts back into the ocean. These dramatic eruptions are called hydrothermal vents. Some look like smoking chimneys. They spew out dark, mineral-rich liquid. These are known as black smokers. This incredible process adds totally unique salts to the ocean, salts that could never come from land runoff. And here's our first wow moment. Around these super hot vents, life thrives abundantly. Special, alien-like creatures live in total darkness. They don't need sunlight to survive. Instead, they eat chemicals from the vents. This is called chemosynthesis. It's like a whole other way life works. This deep-sea ecosystem is powered by Earth's own internal heat. A true marvel of nature, our dynamic Earth itself is a very busy place. Volcanoes, both on land and underwater, play a crucial part. Some volcanoes are on land. When they erupt, they blast enormous amounts of gases. These gases shoot high into the atmosphere. The atmosphere is the air around us. These volcanic gases mix with water vapor. They form tiny droplets in the clouds. Then, when it rains, these droplets fall. They carry dissolved gases and particles to the ocean. This airborne delivery adds another layer of ingredients. These ingredients contribute to the ocean's overall salinity. Other volcanoes are completely underwater. These are called submarine volcanoes. They are constantly erupting on the ocean floor. They release hot gases and molten rock directly into the seawater. These materials immediately dissolve. They add new salts and elements to the water. Imagine tiny, invisible ingredients constantly mixed into a giant global ocean stew. Both types of volcanoes contribute significantly. They ensure a steady supply of various chemical elements for the ocean. Even the countless creatures of the ocean play a vital role. From the smallest plankton to the largest whales, tiny marine organisms use the ocean's minerals. They use them to build their bodies. Think of corals, for example. They build vast, intricate reefs. These reefs are made of calcium carbonate. Clams and oysters make their strong shells. They also pull calcium and other elements out of the water. This calcium is a specific type of mineral salt. When these creatures eventually die, their shells and skeletons fall. They slowly settle onto the ocean floor. This process can effectively remove some elements from the seawater. They become locked away in sediments. But it's not just a one-way street. Other organisms release waste products. These products add different elements back into the water. It's like a giant, continuous recycling system. Every living thing in the ocean has a part to play. This continuous biological cycle helps to balance many minerals. It helps determine the ocean's exact chemical makeup. So now we understand where all these different salts originate. But why do they build up to such enormous quantities? Why doesn't the ocean just get flushed out? The single biggest reason is the power of evaporation. The sun shines down on the ocean's surface. It radiates tremendous heat. This heat warms the surface water. This warming turns pure water into an invisible gas. This gas is called water vapor. This vapor then rises up into the air. Imagine steam coming off a hot pot of water. This steam is pure water. It leaves absolutely everything else behind in the pot. In the ocean's case, it leaves all the dissolved salt behind. The salt and other minerals are too heavy. They don't turn into a gas. They simply stay put in the ocean. This process is exactly like boiling salty water on your kitchen stove. As the pure water boils away, the salt becomes more concentrated. This amazing process happens on a global scale every single second. Pure water evaporates from the ocean. It forms fluffy clouds. These clouds then bring fresh rain. This fresh rain falls back on land or the ocean. But the salt, it always stays put. It is constantly getting left behind. This relentless process makes the ocean saltier over time. Think about the ocean's physical structure. Imagine it as a colossal, incredibly deep bathtub. Rivers are like many faucets. They are constantly pouring water into this giant tub. This river water carries its tiny bits of dissolved salt. But here's the crucial difference. There is no drain for the salt. The pure water evaporates and rises into the atmosphere. It eventually leaves the tub, but the dissolved salt has nowhere to go. It doesn't evaporate, it just keeps collecting. Over billions of years, this simple process has occurred. Small amounts of salt, added daily, add up to truly immense amounts. The ocean is not a flowing river. It's a vast, contained body of water. All the dissolved elements that are brought in generally stay there, unless something actively removes them. This continuous, relentless accumulation is absolutely key. It explains the ocean's immense, unwavering saltiness. It's a perfect trap for minerals. Here's one of the most incredible, mind-boggling facts about our oceans. Are you ready for another wow moment? Even with all this salt constantly pouring in, the ocean isn't getting saltier and saltier forever. It doesn't just infinitely accumulate. In fact, for hundreds of millions of years, the ocean's saltiness has been remarkably stable. It's stayed roughly the same. This is like a giant planetary-scale chemical balancing act. It's an astounding equilibrium. How in the world does this happen? The ocean has incredibly clever ways to remove salt too. Remember those amazing marine creatures? They actively use specific elements. Elements like calcium, silica, and magnesium. They pull these building blocks right out of the seawater. These elements are effectively removed. When these creatures die, their shells and skeletons sink. They form layers of sediment. This process effectively locks some dissolved salt elements away. It takes them out of circulation. Also, tiny clay particles in the ocean water. These microscopic particles have a special ability. They can absorb some ions. Ions are the charged particles that make up salts. These clay particles act like tiny magnets. They attract and hold on to these ions. Then, these clay particles, heavy with absorbed ions, also settle to the seafloor. This removes even more dissolved material from the water. Sometimes, parts of the ocean get completely cut off. They become isolated basins. This often happens due to geological shifts. If the climate is hot and dry, the trapped water evaporates very quickly. It leaves behind huge, solid deposits of salt. These solid forms are called evaporite minerals. This is how many ancient salt mines formed around the world. Think about the Bonneville salt flats. They were once covered by a huge salty lake. When the water dried up, all the salt remained. This is a dramatic way salt is permanently removed from the ocean system. So, the ocean is not just a passive bathtub. It's a dynamic, incredibly active chemical system. It constantly adds salt from many sources, but it also constantly removes it through various natural processes. It's a perfect, delicate, and ancient balance. This amazing balance has supported life on Earth for billions of years. It's a powerful testament to our planet's complexity. And here's the final wow moment. If you could take one typical gallon of seawater, that's about 4 liters, it would contain approximately 1 cup of salt. Imagine that, just 1 full cup of various salts in each gallon. This balance is truly astounding. The ocean is a true master of natural chemistry. It's not just a big body of water. It's a giant, incredibly complex and interconnected system. Every single drop of ocean water tells a profound story. A story of powerful rain, patient rocks, and fiery volcanoes. A story of tiny, industrious creatures. A story of endless, intricate cycles. The salt in the ocean isn't just one simple thing. It's a rich, diverse mix of many different minerals and elements, each with its own unique origin, each with its own incredible journey. This entire grand process took billions of years to unfold. It shaped the very world we know and love today. It created the perfect conditions for life. Our planet is truly amazing. Everything is connected in marvelous ways, from the highest mountain peak to the deepest ocean trench, even the water you drink right now. It is all part of this incredible, ongoing, and ancient journey. What other surprising facts about our oceans truly amaze you? What makes you wonder most about the deep blue sea? Share your thoughts and curiosities in the comments below. We absolutely love hearing your brilliant ideas and questions. Let's keep exploring our amazing world together.